Okay, so the review. Okay, I decided to make videos over the review because I just feel like we didn't really spend as much time as I wanted on transformations because of the circumstances of like the half day on Wednesday and the assembly schedule on Friday. And so I really want you to make sure that you watch these videos and understand or be able to replicate or produce what I'm doing. Okay, so let's take a look. It says sketch the parent function f of x equals x squared. And the reason I have two graphs of the same thing is because I'm going to teach you two different ways to do it. Okay, and so let's take this and I'm going to just draw my parent function 1, 1. And 2, 4, negative 2, 4. So there's my parent function right there. That was interesting. I don't know what just happened. There's my parent function. And then write down the coordinates of the vertex of the g of x and the axis of symmetry and then sketch. So if you take a look, notice that that is you don't have that factored out, the 1/4. That b value needs to be factored out. That whatever that horizontal dilation is, it needs to be identified. So I'm going to rewrite that. I'm going to factor out a 1/4. Let's go ahead and rewrite it with the actual g of x equals factor out a 1/4. When I do that, I'm taking that 1/4 x minus 1/2 and I'm dividing each of these by 1/4. Okay, and then I get a 1 here, x, and then minus, and then 1/2 divided by 1/4 is actually 1/2 times 4. Okay, so that's going to be a 2. And then we have a plus 1. Okay. So what we see here is, let's go ahead and describe. So we have a right 2 and an up 1. Okay. A right 2 is going to be add 2 to the x. Or let's go ahead and write it like that. Add x plus 2, and then mathematically that means y plus 1. Okay, and then you see this 1/4 right there. The 1/4 is, remember, it's inside the function, so it is a scale factor of the reciprocal, which is 4. Reciprocal of scale factor of 4, so that's on the x, so that's going to be a horizontal stretch. What I'm going to do for the first example is I'm going to write a table with each of the points and with a sequence in the correct sequence of how these are going to be using PEMDAS on the original function. So first, if you take a look, I multiply by 1/4. So I'm going to take these and multiply. I'm going to do this first. So multiply that by 4. So I'm going to end up with a 0 and then a 4 and a negative 4. I'm kind of running out of space here. Rewrite that. We have an x and a y. So we have a 0 and a 4, a negative 4, and an 8 and a negative 8. It's going to be 0, 1, 1, and a 4 and a 4. And then it tells us to add it or subtract 1/2. Subtracting 1/2, as we figured out after we factored, it was the same thing as right here. So this is going to be the 2. Okay, so I'm going to take these, do it in different color, and I'm going to add 2 to it. Okay, so that's going to be 2, 0, and then a 6, 1, and then a -2, 1, and a 10, 4, and a -6, 4. And then the last thing is 2. Or you could have done that because that's the only thing that changes the y value. Okay, and then I'm going to add 1 to the y. So xy 2, 1, 6, 2, -2, 2, and then we have a 10, 5, and a -6, 5. I'm going to go ahead and plot those points on here. We have a 2, 1, and a 6, 2, and a -2, 2, and a 10, 5. That's going to be off the graph, and the -6, 5. -6 and a 5. Just like this, and just like this, like that. Now the vertex is now a 2, 1, and the axis of symmetry is x equals 2. Okay? Now, as you can see, you can make a table and you can transition and you can take your sequence. And this is the proper way to do it, but I'm going to teach you another way. Okay? Because this is what my class is all about, finding different ways to do this. So just like before, I'm going to go ahead and factor out that 1/4, and we're going to get the same equation as we did before. Now, all I'm going to do, and here's the parent function. What happened? That is not the parent function there. I think what happened was that I have some things behind the scenes stuff, and I have another OneNote open and it's syncing automatically, and I'm kind of changing this format, and so when it syncs, it updates the graph, and then what I drew on top of it doesn't match up. And if you don't know what I'm talking about, then it's okay. Just understand that this was supposed to be like this. Okay. Now, let's go ahead and draw the parent function here. 0, 0, 1, 1, and then 2, 4, -2, 4. Now, this is the only way that I knew how, the left-handed version. The right-handed version is something that I saw other teachers do in other schools when I was tutoring kids. And I'm like, wow, you could totally do it this way, and it makes perfect sense. So the very first thing I'm going to do is actually just move the vertex. Move it to the vertex and find the vertex. Because the vertex starts at 0, 0. So if you like multiply anything by 0, it is itself. But if you add or subtract numbers to it, then it actually changes. So we knew that it went right 2 and up 1. So I'm going to just go move that vertex right 1, right there. From there, okay, now I'm going to look at the movement. I'm going to look at the movement of where that first point is. I went up 1. I went up 1, and I'm going to kind of change this. I went up 1 and to the right 1. Okay? So I'm going to write that down. Up 1 and right 1. to get to that first point. And then to get to this point right here, from the vertex, I went up 1, 2, 3, 4, up 4, and right 2. Now, from this new vertex, this newly transformed vertex, all you have to do is keep that same movement, but change it based on the scale factor. So the scale factor for this, okay, scale factor for this was 4 on the x. On the x, that would be the right or left. So I'm going to take these values and I'm going to multiply it by 4. So no longer is it a right 1, but it's going to be a right 4. No longer it is a right 2, but it's going to be a right 8. And this is after you've taken that vertex and you've moved it. Okay, so now let's go ahead and do the movement from the vertex. So we're going to go up 1 and to the right 4. 1, 2, 3, 4. And then we can go up 1 and to the left 4. 1, 2, 3, 4. Now it tells us to go up 4. 1, 2, 3, 4 right here. And then right 8. 1, 2, 3. That's going to be off the charts, off the axis. So we're going to go the left 8. 1, 2, 3, 4, 5, 6, 7, 8. Just like so. Negative 6, 5. Like that. That's exactly what I had on the left-hand side. I did not have to go through and make my tables. So once again, translate that main point. It could be a vertex. It could be the 0, 0 of a square root function. It could be the 0, 0 of a cubic function. And then figure out how to get to that first point. And then use those movements and use the scale factor. Kind of like slope. But it has to start from those critical points. Okay? This, the vertex, we just get it from the translations. Okay? And the axis of symmetry also, we get it from the translations. Okay? Good job. Okay, number 2. Once again, I'm going to do it 2 different ways. It is your choice to use either method or understand both methods so that you can check, okay, your work. I always say, like, hey, that's the best thing for you to do. This is once again a quadratic. So bam, 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 2, 4, to negative 4. Ba-da, 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 ba-da. Okay, there's my parent function. So let's look what happened to it. We have to go, let's see, we have to go right 4. And I'm going to write these in order. Okay, and then we have to, as a scale factor of 2 on the y, we multiply that by y by 2, and then we have to go up, no, down 3. Okay, 1, 2, 3. So I can go ahead and write my 0, 0, 1, 1, negative 1, 1. And then we have 2, 4, negative 2, 4. Okay. First thing I'm going to do is go right 4. So add 4. Okay. To the x. So I'm going to get a 4, 0, and a 5, 1, and a 3, 1, and a 6, 4, and a 2, 4. Okay. Now scale factor of 2 on the y, so that tells me I'm going to multiply these by 2. So 4, 0, and then 5, 2, 3, 2, 6, 8, and 2, 8. We're going to go down 3. Down 3, so we're going to subtract these by the y values by 3. So 4, negative 3, 5, negative 1, 3, negative 1, 6, what is that, 5, and 2, 5. Okay, so I take those points, 1, 2, 3, 4, negative 3, okay, and 5, negative 1, 5, negative 1, 3, negative 1, 6, 5, 6, 5, and 2, 5. There it is. And there it is. Right there. Okay. Now the vertex of this is going to be 4, negative 3, and the axis of symmetry is going to be x equals 4. Okay. Now I'm going to do it the other way. Okay. Now remember to do all of your translations. That means all the reflections and everything before you actually get to doing the scale factors of the dilations. Okay, that includes reflections, that includes the translations left to right or up and down. Okay, so let's go ahead and draw our parent function first. 1, 1, and 2, 4, negative 2, 4. There we go. Okay. So we're going to go right 4, and we're going to find that vertex, and we're going to go down 3. Right 4 and down 3. Now from here, once again, it was up 1 and right 1. And then it was an up 4 and a right 2. Right? From the parent function. Now we're going to figure out how that dilation of 2 changed it. We have to multiply the up values by 2. Okay? So now it's going to be an up 2 and a right 1 from the new vertex, and an up 8 and a right 2. Okay, so it's going to be an up 2 and a right 1, or we can do up 2 and a left 1, and then it's going to be an up 8, 1, 2, 3, 4, 5, 6, 7, 8, right there, and right 2, up 8 and a left 2, right there. You see how easy this is? Those are the same points that you had when you made the table. Okay, so that is going to be the vertex. It's going to be 4, negative 3 once again, and the axis of symmetry is going to be x equals 4. So since we're on a roll, I'm going to skip, and I'm going to actually do the graphing part first, okay, and then writing the equations. Okay, hold on, my cats. So I fed my cat. She does whatever she wants. She's the queen. So let's go ahead and first state what kind of function is for both. It's a reciprocal function. Okay, so let's write it up here. It's a reciprocal function. Reciprocal functions look like this. Okay. Once again, the first way, you really can't, I don't know. Okay, the first things to do is identify the transformations. So we know that the x plus 3 tells us that it moves to the left 3. Satisfied with that arrow. Left 3. And it moves up 4. Okay, and then this negative 1 tells us that, notice that that's still inside the function. Okay, that is a reflection over, so the y-axis. It's a reflection over the y-axis. So that means that all the x values you multiply by a negative 1. Now it looks like x minus 1. Multiply. X values multiply by negative 1. Okay, so I'm going to make my table again. And that's going to include, I like to include my asymptotes too. So when x is 0, it's going to be undefined. And then it's going to be undefined when y is 0. And then it's going to be a 1, 1, and a negative 1, negative 1. Okay, for this reciprocal function. Okay, now let's go ahead and list the things that I need to do to it. Well, you can say reflections come first. This is kind of interesting. Now, when you make tables for reciprocal functions, it kind of complicates things. Okay, so I know you see this negative 1 right here. You see that negative 1. Okay. Notice that the parent function doesn't have a negative 1 there. So I have to put that on the x. So I'm going to go ahead and rewrite this. So k of x is going to be 1 over, and I'm going to put that negative down here with the parentheses. Negative 1 and x plus 3 plus 4. Okay, so that kind of shows me that I have to, and if I go ahead and distribute this, it becomes negative 4 minus 3, which changes my left and right movement. My movement still is going to be left 3, but this is the sequence of the transformations, just like the other transformation. Reflections over the y-axis come first. So I'm going to take this and I'm going to multiply all of these x's by negative 1. So go ahead and multiply these by negative 1. Okay, so that's going to be a 0, undefined, undefined 0. Those don't change, but you have a negative 1 and a 1 and a 1, negative 1. Now tells us to do the horizontal translation. So I'm going to make sure I subtract 3 on the x. Okay, so we're going to subtract 3 on the x. Okay, so that is going to be x and y. That's going to be a negative 3. That is my asymptote. That's not going to change. And it's a negative 4, 1, and a negative 2, negative 1. Now at the end, I can do my up 4. Up 4. I have an x and a y. Negative 3, still undefined. Undefined, now my horizontal asymptote is going to change. And then negative 4, and that's going to be a 5. It's at one point in that quadrant, and negative 2, and that is the other point in my other quadrant. So let's go ahead and identify my asymptote, which is going to now be here. And 4, which is going to be right here. And then -4, -4, 5 is going to be here, that point. There is my reciprocal function, and then -2, and then 3. There is my other reciprocal function. Okay? Now, the other way to do it is just for reciprocal functions. Okay? Let's just go ahead and look at the parent function. So we have here and there you go. So we know that that asymptote, this vertical asymptote, is going to go left 3. So let's just go ahead and move that left 3. Okay, let's go ahead and move it left 3 right here. And then that horizontal asymptote is going to go up 4. And then you can take this point right here, 1, 1. That point is going to reflect, okay, over the y-axis right here. And then it's going to go left 3, 1, 2, 3, and up 4. 1, 2, 3, 4. And then this point right there on that parent function is also going to go left 3. Oh, it's going to reflect first. I'm sorry. Reflect over the y-axis right there. And then go left 3. 1, 2, 3. And up 4. 1, 2, 3, 4. I would highly recommend that you do it this way, because as you can see, it's such an easier way of kind of actually seeing with reciprocal functions with it, because you're not taking an entire function like a quadratic with all of these points that come from the movement of the vertex. You're not really seeing that, and there's asymptotes involved in it. So I think that this is the right side way, is the easier way for you to do it. Okay? And good job, guys. Okay, so let's go ahead and rewrite this. K of x equals square root of -2x plus 6. Let's go ahead and factor out the -2. And that's an x minus 3. So we can see the translation. So we know that it is a reflection over the y-axis, which tells us that we need to take those x's and multiply it by -1. We also know that it is going to be a horizontal compression, because the scale factor is going to be 1/2, and you're going to multiply that scale factor by the x, and then you also see that it is going to move to the right 3. Okay, I kind of wrote it in order based on what this tells us, the original, before we factored it out. Let's go ahead and write the parent function. 0, 0, 1, 1, 4, 2. Now multiplying it by a -1 and multiplying it by 1/2. You can add those two. So I'm going to just multiply the x by -1/2. So I end up with a 0, 0 and a -1/2, 1, and a -2, 2. And then right 3 is going to be a +3 on the x. So it's going to be 3, 0. And then that is going to be 2.5, 1. And that's going to be 1, 2. Okay. Now, let's go ahead and graph those. 1, 5. Points. So we have a 3, 0 right there, and then a 2.5, 1, and then a 1 and a 2. And compared to the parent function, which, I mean, I could also reflect it, and you can see 1, 1, and then 1, 2, 3, up 1, 2, 3, 4, 1, 2. It's up 1, 2, and then 1, 2, 4, like that. You can clearly see the points those points got closer together. They got closer together. Okay, so you can see that it's a horizontal compression. When you make sure that the distance from the x's, the different x's got closer together, then that's why the scale factor was 1/2. Now, that's how you use those tables. Now let's use the other method. So I'm going to rewrite that. Okay. And then first I'm going to move that point. So it says 0, 0 and tells you to move right 3. Okay. Now from this point, the original parent function, we have to go up 1 and to the right 1. Or we can go up 4, or it's right 2 and then up, or right 4. Okay, and then up 2 and right 4. Sorry, was a bit distracted because my mom's Leo, my dog, is getting in trouble right now. So that's the parent function. I'm going to stagger that. Okay, and then, I mean, you can take that negative, that reflection, and you can straight multiply. Okay, but we started at this point now, and instead of going up 1 and right 1, now that -2 is multiplying, or the scale factor is going to be a -1/2. And that is actually going to be multiplying the x. So we're going to multiply these. So we're going to go up 2 and right -1, or right 1/2. Well, it's going to be left 1/2, right? You notice that is a left. Left 1/2, and then where did I get the up 2? Up 2, and we're gonna go left 2. So up 1, and then left 1/2, right there, and then up 2, 1, 2, right there, and go left 2. and you get pretty much the same graph as the yellow one on the left. Okay? And that's perfectly fine to graph it that way. In fact, it's kind of, for some people, you're going to think it's easier. Okay? Well, here we have a quadratic. So let's go ahead and change that horizontal dilation a little bit. 3, you're going to get an x minus 2, and then a plus 7. Okay, in order, the things that happen are, number 1, you have a horizontal compression, scale factor of 1 over 3, and that's going to multiply the x. Okay, number 2, you are going to move right 2. And then number 3, you're going to go up 7. Okay, so I have my 0, 0, 1, 1, negative 1, 1, and then 2, 4, negative 2, and then 4. Okay, so horizontal scale factor 1/3. I am going to multiply the x's by 1/3. So I am going to end up with 0, 0, and 1/3, 1, negative 1/3, 1, and 2/3, 4, and negative 2/3, 4. I'm going to include another point that it's going to be easier. 3, 9, and negative 3, 9, because that's divisible by 1/3. And then, so that's going to be 1, 9, and negative 1, 9. Okay, and then it tells you just to go right 2. So right 2. So my x and y now is going to be 2, 0, 2 and 1/3, 1, and 1 and 2/3, 1, and then 2 and 2/3, 4, and 1 and 1/3, 4, and we have a 3, 9, and then a 1, 9. Okay, next it's going to tell you to go up 7. It's going to like do things onto the graph. You might not be able to graph all the points. 2, 7, and then 2 and 1/3, and 8, and 1 and 2/3, 8. Oh, that's definitely going to be all the way up. Whoops. And 2 and 2/3, 7, 11. Yes. And 1 and 1/3, 11. And that was kind of defeated my purpose in creating points that were divisible by 3. And then that's 16, and 1 and 16. Okay, so 2 and 7, 2 and 7. Okay, 2 and 1/3 and 8. I guess I could just put that point on there. 2 and 1/3 and 8, and 1 and 1 and 2/3 and 8, somewhere like that. That's going to be completely off the graph. Okay, so that could have been a way for you to graph it. That's just horrible looking. Something like that. Okay. You know what I'm going to do? I'm going to change this graph. I'm going to make the axes a little bit different. I'm going to make those, disregard the axes. And I'm just going to make 1, 2, and 7. So I'm going to disregard the units. And 1, 2, 3, 4, 5, 6, 7. And then 2, 7, and then 2 and 1/3. 2 and 1/3, 8. Like that. And like that. And 2, so that's 1, 2 and 2/3, 1, 2, 2 and 2/3, 11. And I'm going to actually graph these 2 points. 1, 2, 3, and 16. So that's 8. It's going to be all the way up here on the 16. The reason why I want to do that is it's 1. Remember, this is 1 right here. To show you what kind of horizontal compression is created. This is a significant horizontal compression or a vertical stretch. Okay. Just to show that. Okay. Now, the easy way to do it. K of x equals, let's look at the factored form. Okay. And once again, what I'm going to do is just do the translation. So we had to go right 2 and up 7. I'm going to change my axes here again. 2 and 7 right here. And then if you look at the parent function, it's going to be up 1 and to the right 1. Or you could, you know what? I'm going to do right 1. Right 1 and up 1. Or I could do right 2 and up 4. I could do right 3 and up 9. Input is 3, the output is 9 on a parent quadratic. Okay, now from here you notice that that 3 is going to be 1/3, and you're multiplying the right and left. So I'm going to multiply all of these by 1/3. So now you're going to go right 1/3 and up 1. So right 1/3 and up 1. Left 1/3 and up 1. And then multiply that by 2/3. So right 2/3 and up 4. So right 2/3 and up 4. 1, 2, 3, 4. And 1, 2, 3, 4. Okay, and then right 1 and up 9. Right 1 and up 1, 2, 3, 4, 5, 6, 7, 8, 9. Right up here. It's going to be the same right here. Once again, it's that significant horizontal compression that occurred. Okay? And good job. Okay, wow. This one's kind of crazy. Okay, let's go ahead and rewrite it. G of x equals 1/4. Take out a -1. We get x plus 2 minus 1. Okay, now I'm going to list these in order. Number 1, it's a reflection over the x-axis, or a scale factor. Oh, not a scale factor. Sorry. A multiplication of the x by -1. Number 2, Okay, we're going to go left 2. Number 3. That should be a 1. It's horrible. 1, and that's a 2. Okay, so that is a vertical compression, and the scale factor is 1/4, and we're going to multiply that by the y's. And then number 4, we go down 1. Okay, and I'm going to show that on my table. 0, 0, and 1, 1, negative 1, 1, and 2, 4, and negative 2 and 4. Okay, so first we are going to reflect those by negative 1, multiply the x's by negative 1, multiply by negative 1, so x and y, 0, 0, negative 1, 1, 1, 1, negative 2, 4, and 2 and 4. Notice that it doesn't do anything. Doesn't do anything. Okay, because the reflection over the y-axis for a quadratic is itself. Okay, but we're just doing exactly what they're telling us. Okay, and then we're going to move it left 2, so that's going to be a minus 2 on that. So it's going to be a minus 2, 0, minus 3, 1, minus 1, negative 1, 1, and a 0, 4, and that is going to also be a 0, 4. It's going to be 0, 4, 0, 4. Okay. Wait a second. No, it's not. What in the world am I thinking? It's a negative 4, 4, and a 0, 4. Okay, now we're going to do a vertical compression scale factor of 1, 4. So we're going to take the y values and we're going to multiply it by 1, 4. That's a multiplication thing. Multiply by 1, 4. So xy, negative 2, 0, negative 3, 1/4, negative 1, 1/4, negative 4, and that's going to be a 1, and a 0, and that is going to be a 1. And some of you guys could do it all on the graph, and that's fine. That is perfectly fine. Okay, and then down 1, so minus 1. So x and y, 2, negative 1, negative 3, negative 3/4, negative 1, negative 3/4, negative 4, 0, and 0, 0. Let's go ahead and plot those. Negative 1, negative 3, and negative 3 points there, negative 1, negative right there, negative 4, 0, and 0, 0. Ba-bam. Ba-bam. Okay? Just so that Shriram doesn't... There you go, Shriram. Okay. The very straightforward, simplified way of graphing it, 1/4. Let's go ahead and factor that out. X plus 2 squared minus 1. So we know it goes left 2 and down 1. So left 2 and down 1. Okay, and that's going to be a right 1 and up 1 and a right 2 and up 4. right? When you have an input of 2, you get an output of 4. You can do other things like right 3 and up 9 from the parent function. So we can take those, and as you can see, the -1 doesn't really do that much to it. I mean, it's just going to take these right. Instead of going right, you're going to go left, but we're going to go left anyways because it's, I mean, symmetrical. The parabola's symmetrical. I mean, if you go right up, I mean, right 1 and up 1, it's going to go left 1 and up 1 too. So it doesn't really matter. So I could just take these values right here and just multiply it by 1/2. Nope, you're not going to do that. It's not 1/2 either. Wow. This is what happens. You take those values and multiply it by 1/4 because that is happening to the outside of the output. I mean, the outside of the function or the output. So it's going to be, here we go with Leo, right 1 and up 1/4 and right or left 2 and up 1 and then right 3 and up 9/4. What's 9/4? 2.25? Yeah, 2.25. Okay, so let's go ahead and do that from the vertex. Right 1 and up 1/4, left 1 and up 1/4, and then right 2 and up 1, and then left 2 and up 1, and right 3, 1, 2, 3, and that's 2.25, 1, 2.25, left 2, 1, 2, 3, left 3, and up 1, 2.25, right there. There we go. So once again, you can either choose. You can make the tables. You can just draw the parent function, and you can just move those. If you understand vertical and horizontal dilations, then you could just multiply those by the scale factor. Or you could write it out this way on the right, and then just use that vertex. Okay? Good job. I think that's all of the graphing. Okay, yes. Okay, so now we're going to try to write the equation from the graphs. Okay, first of all, it says describe what happened. Okay, for the first one, you see that the origin didn't change, so there was no translations. The translations are left or right. Up and down movements. Okay, so you know that there was no translation. So once again, I could write g of x with x squared, or I could write g of x with a universal function notation. Okay, which tells us what happened to f. And so there's not going to be any kind of add-in that happens, nothing that gets added or subtracted. But one thing that you do see is that a right 1 and an up 1. Okay, let's write it down here. Right 1 and an up 1. Okay, changed into a right 2 and an up. A right 2 and an up 1. Once you understand that, oh gosh, dilations are so easy to figure out. Okay, then you can look at another point. Okay, you can look at another point. You can look at this point right here and say you can go right 2. Okay, and then up 4. And then you could possibly we took that point to from there, and then we took this point to there. And then so you could see that it was right 1, 2, 3, 4, right 4, and up 4. Okay, so what change happened? Let me go ahead and change the picture. What change do you see? What is that scale factor that produces right 1 to 2 and 2 to 4? You have to multiply it by 2. You have to multiply those things by 2. Okay? Now, if you look at the right or the left, okay, if you look at the right or remember I told you stop trying to move from the origin to the transform function. Snap it back to the origin or snap it back to the original point. So if you actually think about it and go the other way, okay, we are reducing it by 1/2. And that's confusing. Okay, so I'm going to leave that off. So that was a scale factor of 1/2 on the x. A scale factor of 1/2 on the, of 2 on the, of 2 on the x. Okay, so you know that that's going to be inside the function. So it's going to be g of x equals, open up that function. It's going to multiply that x by a number. Okay, remember, we have to take the reciprocal. So 1/2. Okay, if I wanted to write it as a universal function, that's g of x equals f and then 1/2 x. Okay, this one, once again, it's a quadratic, and so I could write it both ways. Okay, oh, that's nice. Ooh, look at all those different yellows. Let's use an orange. F of x, or g of x equals f of x universal way, and then g of x equals just pertaining to specific quadratics, which this is. Let's take a look. Okay, so you know that there was a reflection, okay, over the x-axis. So how is that going to change? Reflection over the x-axis. So reflection over the x-axis means that the y's will be multiplied. So we have to take it like that. Okay. Now you can clearly kind of see that there is some kind of dilation that happened, because once again, if I take this and I go right 1 and that's not gonna work. That highlighter is useless. Okay, so right 1 and up 1, right 1 and up 1. And you can write this as a table too. I mean, it's up to you. Okay, and the other thing, you can say right 2 and up 4. Let's see what happened here. Okay, we know it's going to go down. Okay, because we've reflected over the x-axis. So we could just say right, looks like 1, still 1. Let's go ahead and get rid of all of these things. Okay, right 1, but it looks like down 2. Okay, I'm just gonna say up 2 because we already know that it reflected. Okay, we already know that it reflected. So I'm just gonna write up 2 because I'm just focusing on that scale factor, not multiplying it by a negative, which we already indicated. Okay, or we can go right 2 and 1, 2, 3. It doesn't even show. You can't even see it, right? Yeah, you can't even see it. 3, 4, 5. It's off. It's off. We don't even know. Up. I don't know. Okay, it's off. I'm guessing that it is probably going to be 8. Okay, 1, 2, 3, 4, 5, 6, 7, and then 8. It's going to be a point here. I have a feeling. Okay. Now, let's go ahead and try to figure out what happened from 1 to 2 and 4 to 8. We multiplied it by a 2. Multiplied it by a 2. Okay. Now, let's think about that. Okay. The up multiplied. So that's a vertical stretch. Elongated this. It's a vertical stretch. Okay, so if you think like, hey, it's a vertical stretch, that would be multiplying the y's by 2. It's going to be outside of the function. It's going to not be a part of that parentheses or the square root or the absolute value where the x is contained, because we're multiplying the outside of the function. So this is going to be g of x. Wow, Leo's just going bonkers. Negative 2 f of x. And remember, we don't take the reciprocal. Okay? Good job, guys. Okay, let's take a look at the next one. Okay? So, there's our point, there's our vertex. Let's go ahead and first figure out the movement of the vertex. So we've moved right 3 and up 2. So let's go ahead and start making our function. G of x equals x squared, and f of x equals, oh, what in the world? What am I doing? Okay, g of x equals f of x. Universal function, either way is fine. Either way is fine. But you have to know both. Okay? So g of x with that translation is going to be at x minus 3 to the second, because the plus 3, it goes back in. F of x minus 3, and then up 2. There we go, up 2. Okay, now let's figure out the dilation, if there was any. Okay, right 1, up 1. Right 1, up 1. Right 2, up 1, 2, 3, 4. Right 2, up 1, 2, 3, 4. No dilation whatsoever. Okay? Good job. Next one. Okay. There is the vertex. There is the vertex. Let's see what happened to it. We moved left 1, 2, 3. Left 3. And down 1, 2, 3, 4, 5. Down 5. Let's go ahead and write our two functions. G of x equals x plus 3, remember minus 3, that's minus 3. Flip the sign, squared minus 5. Or g of x equals f x plus 3 minus 5. Now let's see if there was any kind of dilation that occurred. Using that up, right 1, up 1. Right 1, oh look, let's go ahead and write that. Right 1, up 1. 1, 2, looks like 2.5. Doesn't it? Doesn't it look like 2.5 right smack dab in the middle? So right 1, and up. Oh, I'm sorry, 1.5. 1.5. Okay, 1.5, or that's 3 halves. 3 halves. Okay, and then we could try another one. We can try right 2, up. Right, let's just write it shorthand. Right 2 and up 4. It's going to be right 2 and 1, 2, 3, 4, 5, 6. Right 2 and up 6. Okay, so it looks like from here to here we multiplied by 3 halves. Is that true for this? 4 times 3 halves is 6. So we're multiplying these by 3 halves. Now, once again, that's the y value that we're multiplying by 3 halves. That would be a vertical, and this is 1.5. So that is greater than 1. So that's a stretch. Does it look like it vertically stretched? It does. This looks a little bit rounder than the other one. This is the green parabola, looks a bit sharper, doesn't it? Once again, you can think of it as a horizontal compression. Yeah, it looks like it kind of squeezed in a little bit. Okay, and so that vertical stretch, we multiply the y values. That is going to be outside of the function. We take that directly in there. Okay, we don't take the reciprocal. G of x equals 3 halves times x plus 3 squared minus 5, or we can write it as a universal function form, x plus 3 minus 5. Okay? Good job, guys. Next. Okay, so let's take this. Okay, copy the graph of f and draw each function on the same axis. Okay. This is a piecewise function. This is very similar to 3.4 that you did, except I did not ask you to write the equation of the piecewise function or anything like that. It's just telling you to just go ahead and transform it. Okay, so let's go ahead and take A, and we're going to just take these points and we're going to reflect it. So what I'm going to do is I'm going to draw the original function on here. Keep it this red color, and then 4, and then 6, 1, like that. Oh, whoops. Like this, and then 1, 0, and then 1, 1. And then -1, 2. The cat, after having been fed, is now going bonkers in this room. And then -3, like that. Okay, let's see if we could find enough colors. Okay, let's do A in blue. So we're going to reflect these over the y-axis. And so I'm going to take that. So 1, 2, 3, take that point right there. Oh, 1, 2, 3, sorry. That point is going to be like that. Okay, and then it's going to come down to here. Take that, reflect that. Ba-bam. And then take this. Ba-bam. And then 4 is going to reflect off to here, and then 6 is going to be right there. Okay, so that is A. And then we're going to take B, and we're going to use a different color. And that is going to reflect the original function over the x-axis, right? Yeah, because the y's get multiplied by -1. Y's get multiplied by -1. So I'm going to take this and then move it here. Take that and then move it here. Take that point and move it there. That point is going to stay as is. That point is going to reflect over to here. And then once again, they're going to meet right here. And then that point gets reflected there. There you go. And that's going to be B. Okay, C is where we take each of those points and we multiply the x by 1/2 right here. We multiply the x by 1/2. So I can make a little table. I'm going to use a different color. Let's use orange, x and y, and maybe -3, 2, and -1, 2, and 0, 1, and 1, 0, and 2, -1, and 4, 0, and 6, 1. Okay, and then I'm going to take the x values and I'm going to multiply the x values by 1/2. You have to take the reciprocal. So that is going to be xy. So -3/2 over 2, -1/2 over 2, 0/1, 1/2 over 0, and 1/-1, and 2/0, and 3/1. So -1.5, -1.5 right there, or 2 right there. Okay, and then -0.5 to 2. Yikes! Okay, there is a little scrunched up horizontal line now, and then I'm going to 0 and 1. Okay, and then 0, 1, and then 1/2, 1/2, 0. I'm not liking this. Okay, 1/2, 0. Okay, 1/2, 0, and then 1 and -1. There was that point. Okay, that got vertically compressed. See that? Okay, 1 and -1, 2 and 0, 2 and 0, and then 3 and 1. Now you can see from the parent function that all of these points ended up getting vertically, or I'm sorry, horizontally compressed. They all went into, all of them went in. Okay, and get rid of the arrows. So the orange was C. Okay, now for D, let's go ahead and pick another color. What other color? Purple. Okay, purple. Now I'm going to take all the points and I'm going to multiply it by 3. Multiply that y value by 3. That's going to be a vertical stretch. Okay, so we have a -3 and a 6, -1 and a 6 and a 0 and a 3, 1 and a 0 and a 2 and a -3, 4 and a 0 and 6 and a 3. So -3, 6, -3, oh, that's off the charts. -3, 6. That's 5, 6, -3 and 6. Okay, just became another point. And then -1 and 6. Okay, -1 and 6. And 0 and 3. And 1 and 0. And 2 and -3. And 6. Oh, 2 and -3, 4 and 0. And 6 and 3. It's a major vertical stretch. Wow, this is turning into a mess, isn't it? This is turning into a mess. Okay. Next, we have E. Okay, I hope you can decipher this. Okay, E, we're just going to take all of those points. I don't even know which one is my original function. Okay, I'm going to make it bold. No, I'm not. Okay, I'm going to take all of those points and move it left. It says left 6. Okay, let's go ahead and use this lime green right here. Move it left 6. So that point is going to move left 6. So 1, 2, 3, 4, 5, 6. And then that point right there, I'm going to move it left 6. Was it that point? Where was it? -1. Okay, -1. And then 1, 2, 3, 4, 5, 6. There's my horizontal line. And then move that 6. 1, 2, 3, 4, 5, 6. Then move that point 6. 1, 2, 3, 4, 5, 6. And then move that point 6. 1, 2, 3, 4, 5, 6. And then move that point 1, 2, 3, 4, 5, 6. Move that point 1, 2, 3, 4, 5, 6. So now that is going to be E. And then now we're going to move everything down 3. Okay. What color? What color does this create? Oh, okay, that's interesting. That's an interesting color right there. Down 3. Okay, so we're going to move 1, 2, 3. And then 1, 2, 3. Okay, 1, 2, 3. And I can just move that point. 1, 2, 3. That should be able to fill in the gaps. It looks like it has the same slope. And then 1, 2, 3. Looks like a bunch of mess. 1, 2, 3. Right there. And that ends up becoming F. No wonder Himasuri has so much fun with this. Okay. Good job. Next. Number 8. Whew. Okay, so what we are looking at over here is F. Okay, F right here and right there. F is that function, and everything got transformed from it. Okay, so if we have f of x, and we don't have to write an equation for it. Okay, and then we could just transform it, and it's going to either become s of x, or it's going to become, I should not put in implies, it's going to transform, and it's going to become r of s. And then we have to figure out which kind of, what kind of things happen to it. Okay, so for s, first of all, let me go ahead and erase this so I can clearly see. It looks like there was a reflection, okay, over, if you look at that point and that point, it was a reflection over the x-axis. Okay, so for s, it looks like there is a reflection over the x-axis. So this reflection, let me go ahead and write it. Reflection over x-axis. Okay, and then it seems like that point moved, or I can take this point right there and reflect it, and or I can take that point right there, and that one reflects to here, and then it moves 1, 2, 3. Okay, 3 to the right. Right? Flexion over the x-axis, and it moved 3 right. Okay, so that could tell us that f of x to become s of x. So s of x equals f of x minus 3. Okay, that's 3 to the right. And then a reflection over the x-axis is going to be multiplying that by a negative. Now, if you look at r, it definitely looks like a vertical stretch. Okay, it looks like a vertical stretch. Okay, and so that means that to create r of s, okay, f of x, it doesn't look like the points moved anywhere. Okay, but if I take, for example, this point right there, and it became that point, that's a 4, and that's an 8, so it's doubled. And if you look right here, that looks like a 3 and becomes a 6. 3 and a 6. Okay, so it's doubled. Just like that. It doubles the y values. Okay, number 9. Here's your f of x right there. Okay, let's look at s. S, from what I see, just looking at that horizontal line, and that horizontal line is stretched out, so that looks like a horizontal stretch. Okay, so to create s of x, and then it also looks like I'm just going to take this point right here. Okay, 0, 0 went down 2. Okay, so that means that F, we're going to have to put some kind of value there because it's a horizontal stretch. Okay, but it went down 4. The y values went down 4. So the horizontal stretch, and if I take a look, a 4 became an 8. So you have to multiply 4 times 2 and it becomes 8. So that is a dilation. Or you can take this 2 and it becomes a 4. Or this 2 becomes a 4. So you're multiplying both of those by 2. But when you put it inside the function, okay, and we have to take the reciprocal, so that becomes a 1/2. It becomes a 1/2. And then if you take a look at r of x, okay, that, I'm just going to erase all of this. That just looks like a straight reflection over the y-axis. Reflection over the y-axis. So if you reflect something over the y-axis, the x's become negative. So that's f of negative x. Okay? Was that all of them? I could have done like 14 more. Okay. Well, good job.